Good morning students, welcome to basic electrical lectures, and we already covered module 1 as per VTU syllabus. One more lecture I am going to upload in module 1, that is problems on AC fundamentals. So soon I will upload in the middle of module 2 lectures. So today we can start module 2, and in module 2 we have two parts. First part is single phase AC circuit and the second part is three phase AC circuit. See, in this part, so lot of derivations are there. Okay, once you have understood the concepts of derivations and the concept of all these various circuits, so you can easily solve the problems. You must watch the theory lectures in detail, okay, without forwarding. So you will get strong concept. So using that concept, you can solve problems in a confident manner. Okay, so very much important. So once you understand single phase AC circuits, the second part is very simple, three phase AC circuits. So for passing purpose, some students or if you are thinking for only passing purpose, you have to study all the circuits theoretical part in detail. Okay, definitely 5 to 10 marks they will ask in this particular module. Okay, but problems are very important. Okay, we cannot predict. VTU sometimes they will ask more problems or more theory. So both possibilities are there. So since we are students, we have to prepare whatever in the syllabus is there. We should prepare in detail, in depth, so that we can score full marks. We can start class number 1 of module 2. So in single phase AC circuits, generally what we are studying means we are studying the behavior of the circuit. Okay, so the following circuits are pure resistive circuit, pure inductive, pure capacitive circuit, series RL circuit, RC circuit, series RLC circuit, parallel RL circuit, parallel RC circuit, and then parallel RLC circuit. And the last one is combination of all this. Okay, series parallel combination. Guys, the first three topics, okay, pure resistive circuit, pure inductive and pure capacitive circuit, they won't ask any problems on these three topics. Okay, they will ask only derivations. Okay, only derivations. The first three topics, only derivations. But if you understand these three topics in depth, other topics are very simple. Okay, next remaining topics, series RL RC and parallel RL RC and RLC. Okay, series parallel. So they will give more weightage on problems. On these topics, they will ask more problems. However, they will ask only one theory question, that is derivation. They will ask derived power is equal to VI cos pi in the following circuits. Okay, got it? So this question rarely they are going to ask. But till now, for 18 scheme, you are writing 5th time. So you are getting question paper at 5th time. Already 4 times exam is done. So 5th time. So I referred all those papers. They asked problems. Out of 20 marks in that particular module, 12 marks they asked problems, 8 marks they asked theory. So all the problems will be in this combination only. Okay. So we can start the topic pure resistive circuit. Okay. Fine. Pause the video and then copy down. So totally 9 circuits are there. We have to study all those 9 circuits in detail. Okay. So let's start with first one. So pure resistive circuit. So what do you mean by pure resistive circuit? The circuit consists only resistance. It's called pure resistive circuit. So we can write the diagram like this. So it is a resistance, and I applied AC voltage. Now I am discussing AC supply. So apply instantaneous voltage. Okay, V is equal to Vm sin omega t, and this is the resistance R. And some current flows through this resistor. See, this voltage source will drive the current in this circuit. So before solving, for example, we should take the either voltage or current as reference. Okay. So, but this circuit is neither series circuit nor parallel circuit. See, If you see the circuit meant, what is the common parameter? Current should be same. See, same current flowing through the element. What about voltage concept? Voltage across each element will be same. Since we have only one element, across the resistor, same voltage is there. So voltage and current both are matching. So therefore you cannot say this is only series circuit or only parallel circuit. It is simply a closed circuit consisting of resistance. In order to decide series and parallel circuit, minimum two elements should be there. Minimum two elements should be there. Then only we can say series or parallel. For example, see now two resistors I have written. Now you can say confidently it is series circuit. Okay. Now two resistors I can connect like this. Now you can say it is parallel circuit. Okay, got it? So here current will be same, here voltage will be same across the elements. So we can derive this. So from Ohm's law, we know that what is current equation? I is equal to V by R. So now I is equal to, substitute this V here. Substitute this V here. So what you will get? Vm sin omega t divided by R. So now I will take Im is equal to Vm by R. This voltage by resistance will get maximum current. Using this notation, I am modifying this. So I is equal to Im sin omega t. So what is this? This is the current flowing through the resistor R. Okay, understood? So we applied this much voltage, okay, and I determined how much current is flowing. The current flowing through the resistor is Im sin omega t. In instantaneous quantities we have written. So pause the video and then copy down. So next we can draw the phasor diagram and waveforms. Okay, look at here. First we apply the voltage. So we apply voltage to the circuit. Okay, apply the voltage, sinusoidal voltage. We already know that in AC fundamentals we can write this Vm sin omega t sine waveform. So write a sinusoidal voltage waveform. So you should write this and this with almost equal proportional. Okay. So this is the applied voltage. Then what is the current flowing through the circuit? Current also same, Im sin omega t. See, there is no phase angle between voltage and current. Means it is zero phase circuit. Pure resistive circuit is having zero phase difference. Okay. See, with respect to voltage, current also follows the voltage. So therefore, current waveform we can write like this. So this is the current waveform. So this red color what I am writing, it is current waveform. So current waveform I can write I is equal to Im sin omega t. Okay. What is voltage waveform? V is equal to Vm sin omega t. So I written both the quantities, current and voltage. Now write the phasor diagram. What is the reference you have taken? What is the reference you have taken? Voltage. Okay. Voltage is the reference phasor. We have to rotate this phasor in anti-clockwise direction. If I rotate this phasor in one anti-clockwise direction, we get one alternating cycle. Similarly, what is current flowing through the resistor? Im sin omega t. So this is current phasor. So current phasor coincide with the voltage phasor because the minimum value and the maximum value attains at the same instant. See, at instant t equals to 0, voltage and current both attains minimum, and at this instant voltage and current attains maximum value. Means at all the instants current waveform follows the voltage. So therefore this circuit, pure resistive circuit, we can call it as in phase circuit. Okay, and the phase angle is nothing but angle between two quantities, voltage and current. What is the angle between voltage and current from this phasor diagram? 0 degree. What is the phase angle in pure resistive circuit? 0 degrees. Okay. Sorry. So you have to write the phasor, reference phasor on the x-axis. Okay. Reference. What is the reference? Voltage. I taken voltage, then I determined current. So current in phase with voltage. Okay. So this is waveforms and this is phasor diagram. This one is phasor diagram. See now, next we need to derive what is power consumed in pure resistive circuit. Look at here. What is power formula? Voltage into current. What is voltage? Vm sin omega t into what is the current? Im sin omega t. Multiply this two, you will get Vm into Im. What is sin omega t into sin omega t? Sin square omega t. So sin square omega t, you write the trigonometric formula. What is the trigonometric formula? 1 minus cos 2 omega t divided by 2. Now multiply this. If I multiply this, I can write like this. Vm Im by 2 minus, so this into the second term. Vm Im cos 2 omega t divided by 2. So now the instantaneous power, okay, this is instantaneous power is equal to instantaneous voltage into instantaneous current. Sorry. See now, the instantaneous power having two components. Okay. So the first component is nothing but average component. So it is average power. Okay, average component, and second one is fluctuating component. And the second one is fluctuating component. So we have two powers. Instantaneous power is resolved into two components, average component and fluctuating component. See, the fluctuating component, okay, means having double frequency. Fluctuating component means double frequency, either cos or sine, any trigonometric terms having double frequency. If I integrate the fluctuating component over one cycle, its average value always become 0. Okay, so therefore I am writing the arrow mark. This fluctuating power will become 0. So please write here, I will dictate one point why I cancel this to 0. So copy down. If we integrate the fluctuating component, over one cycle, its average value is always 0. I repeat again. If we integrate the fluctuating component over one cycle, its average value always 0. Okay, its average value always 0. Full stop. Therefore, power is consumed only due to average component. Therefore, power is consumed only due to average component. Therefore, the power is consumed only due to average component. Okay, got it? Fine. See, blindly, fluctuating component means double frequency. Okay, so this is single frequency. So double frequency means in one voltage cycle, we get two power cycles. Okay, we get two cycles. What is the quantity? Power. So if you get two cycles, if you integrate the average value over one cycle, okay, of double frequency components, it becomes always 0. Okay, got it? So therefore, now you can write. Next step, you can write power is equal to Vm Im divided by 2. So this power is nothing but average power. Therefore, I will write capital letter. So now this 2 I am modifying as Vm Im. 2 can be written as root 2 and root 2. Multiply. Root 2 is root 2 whole square. Again you will get 2 only. Now therefore power is equal to, what is Vm by root 2? Vrms. So RMS value is written in capital letters. What is Im by root 2? IRMS. Im by root 2 is IRMS. Write in capital letter. So therefore what is power consumed in pure resistive circuit? What is the power consumed in pure resistive circuit? Power is equal to VI. What is the unit? Watts. So unit is watt. See, now I will explain now why we made it into 0. You will get 2 cycles of power waveform over 1 cycle of voltage waveform. See, now multiply this 0 into 0, 0. Okay. Voltage is positive, current is positive. If I multiply this, so you will get power like this. The power value increases. Finally it reaches maximum value at some instant, and again, because both are maximum, power also maximum, and again the power values decreases. Okay, finally at this instant you will get 0. So similarly, negative to negative, so you will get negative power. So negative is positive. If I multiply these two waveforms, you will get a power waveform positive. So it reaches to maximum value at some instant, and again the power value becomes 0. Okay, got it? So we can write like this. So this is the power waveform, green color. Okay, it is power waveform. What is this power? Instantaneous power. Okay, but the power is consumed due to average component. So power is consumed due to average component. So what is average power? What is this value? Vm. What is this value? Im. What is average power? Vm Im by 2. So in the middle you will get average power. So what is the average power? P average is equal to Vm Im divided by 2. Vm Im divided by 2. So got it? So this is the power, average power. Understood? So power is a scalar quantity. You will get average power only. So next, observations or note. See, all these observations will ask in Viva. Observations. So we can predict these questions in Viva. Okay. And these points, observation points, are very much required while solving problems. Okay guys, write on first point. Pure resistive circuit is also called in phase circuit. Pure resistive circuit is also called in phase circuit. Okay, that is the first point. Pure resistive circuit is also called in phase circuit. Okay, next, second point. The phase angle between, write down, the phase angle, so phase angle denoted by pi. Okay, the phase angle between voltage and current, the phase angle between voltage and current for pure resistive circuit is 0 degree. Okay, is 0 degree. So what is the phase angle in pure resistive circuit? The phase angle nothing but angle between voltage and the current. That is called phase angle. So how much you will get? 0 degree. Okay, understood? Next, in pure resistive circuit, the power factor is unity. In pure resistive circuit, the power factor is unity. In pure resistive circuit, the power factor is unity. In pure resistive circuit, the power factor is unity. Okay. So how? See, power factor formula is cos pi. Okay, cos pi. Cosine of the angle between voltage and current is called power factor. So what is pi value? 0 degree. Put pi is equal to 0 degree here. What is cos 0? 1. So therefore, in pure resistive circuit, the power factor will be unity. The power factor will be unity. See guys, if you multiply this waveform, you will get voltage and current waveform, you will get power waveform. See, for one cycle of voltage waveform, how many cycles you got power? See, from here to here, one cycle power. From here to here, another cycle. That is called fluctuating power. having double frequency, its average value over one cycle, it's always 0. Okay, got it? Fine. So guys, this completes pure resistive circuit. So remember only this observation points while solving the problems. So guys, please like the video, share the video and subscribe. Tell your friends to watch electrical lectures. Okay, so today I will upload around 3 to 4 videos. Okay, in the next video I will upload pure inductive circuit. Every circuit I will put one video. Okay, have a nice day. Take care. Bye bye.